Hi, I'm Phil, and today we're going to look at FarmBeats and my Raspberry Pi Model 5 upgrade to it. So let's have a look at the projects. I've done quite a few projects so far. We've done Sense Hat, we've looked at the Automation Hat, and the one I'm going to look at today is continues on from our communications projects. So we're going to look at FarmBeats. And let's have a look at the original FarmBeats. So around about 2020, FarmBeats was quite popular, and it was introduced by Microsoft. So let's just have a look at that. So the original FarmBeats project, we'll look at some of the objectives. It was to collect data relevant for farming and do some analysis on parameters such as soil moisture and temperature and relate that to plant growth. So it was also measuring environmental parameters like air temperature and humidity. I've added the pressure, but it also looked at the ambient lighting level. And the original one measured both the visible and the infrared radiation. It was also going to control water with a relay and then a water pump. But I've also added the light control. And the original FarmBeats used machine learning, and that could be used to measure plant growth and also to identify plants using machine vision. So the partners to that were Microsoft, and they worked with the National Federation of Farmers in America and put together with Seed Studio a kit that provided sensors and actuators for FarmBeats. And in Australia, the CSIRO had a pilot project working with schools, around about 18 schools and just under 400 students, mainly from years 9 to 10. But some schools involved year 12 students in some of the more advanced aspects. So you can see what the kit looked like. So this is what the kit was provided by Seed Studio. And this is my configuration of the original. So you can see that it's sitting on top of a Raspberry Pi. And right on top, we've got the special version of the Grove hat. So this version includes a fan that only came out with the FarmBeats project. So there you've got all the components, and you had communications going from the GPI pins for transmit and received, and that tapped into a UART, converted it to USB, and you had data available on a remote PC. So students could put all that together in a box and do the analysis on their PC. So the analysis looked a bit like this. Using a program called Data Streamer, it was able to feed live data into Microsoft Excel, and Microsoft Excel could not only graph and show you the parameters, but could also provide control to turn on the water pump via a relay. So the hardware consisted of the Grove resources put together by Seed Studio in a kit, and that sold for just under $80, not including the Raspberry Pi 4 computer. And you could use a camera So Microsoft also provided Loeb. You could use Excel, and Loeb allowed you to do some machine vision. And you used your Windows PC camera for that. But it would have been better to use the Raspberry Pi camera. Okay, so that's some of the references for the original FarmBeats project. Now, my project is to get all working on Raspberry Pi Model 5 in the operating system called Bookworm. And what I've done is I had a lot of trouble with the the Grove hat. So I've decided to provide a interface outside of the hats, and we'll see that in a minute. So this is my desktop arrangement. Right on top, I'm still using one of the Grove hats, and there is only one. And during COVID-19, Seed Studio had a problem sourcing the microcontroller on the Grove hat, and that microcontroller was a SMT 32. It couldn't find those, so it replaced it with an MM32. And this particular one is the only one that works with the Grove devices and onto the Grove hat on Microsoft Model 5. And what I'm using is the microcontrollers. So I'm not using the Grove hat. I'm using this instead. But I'm still using the original Grove components. And I've got a carrier, a Grove carrier for the Arduino Nano. And that's this red computer here with the carrier to the Grove components. So you can see my desktop arrangement, and it's ready to go into the farm. So let's have a look at what my objective is. I want to design a simple replacement for FarmBeats, and that replacement will allow Model 5 to work with my upgraded version. And I also want to select formats for the data. So it can either be CVS for Microsoft Excel, or alternatively, I can use the JSON format. And I'll use a special Arduino JSON library to do that. And I want to be able to measure soil temperature and moisture, just like the original. And instead of just humidity and temperature, I'm going to add pressure using a BME 280. And the original one used the sunlight. And there was a more recent version of that omitted the ultraviolet radiation. I'm going to replace that because I found it didn't work that reliably. And I'm using a digital light meter, which will measure directly in lumens. And I'm going to do exactly what they did originally. I'll use a relay for controlling the pump. So if the water moisture is low, that is, the soil is dry, it can switch on the pump. And I want to look at unit tests and aim for FarmBeats compatibility and also for JSON compatibility. And I'm going to use Node-RED, and Node-RED will add the timestamp. So we might look at that JSON format. So you can see in the library, I'm putting all these together in an array doc with different components, and I can transmit those in the JSON format. And we'll have a look at that in a minute. Alternatively, my Raspberry Pi can issue commands, and one of them is that it wants to get the data in CVS format for Excel. Okay, so in the design of my system, this is my protocol. Um, it will work with the sunlight, but if we look at the digital light sensor, this is the parameters in the serial string. And my system is going to be 3.5 volt everywhere. So that'll make it a little bit easier. And I'm using UART comms and Grove components. So we'll look at the hardware. So hardware-wise, I'm using Seed Studio components, just like in the original, but instead of the microcontroller on a Grove hat, I'm using the Arduino Nano with a Grove carrier. And I can either use the Grove sunlight sensor or the Grove digital light sensor. And I'm also using the one-wire temperature probe together with the capacitive soil moisture sensor, a relay, and that's all the components. And they all go in this configuration. So they're very similar, either with the Grove sun sensor or the Grove light sensor. Okay, so we might have a look at some of the software. For the Nano, I'm doing everything in C++, and it's all going to go on the Arduino IDE for development. So I'm going to start off with unit tests. So I want to make sure that I understand and can program each of the individual devices. And I'm using C++ to do that. And I'm testing that also on Node-RED. The program that, putting all that together, the program I've come up with is this one. So we might actually have a look at that now. So there's the program, and we'll have a look at the libraries. So I'm using libraries on one wire, the Dallas temperature for the temperature probe, Arduino, the BME 280, and instead of using this one for the sunlight, I'm going to use the digital light one as an alternative. Okay, so we might close that one and have a look at the latest one. So instead of using the sunlight, I'm using the parameters here and a slightly different set. So you'll see that I'm using the digital light set library here in the code. So we might go across and have a look at that code now. We'll go across to the Arduino. So this is my program, and I'll just quickly walk through it. So you can see I've set up the library here. We've got all the components, and you can see where I've replaced the sunlight sensor with the digital light sensor. I'm declaring the global variables right up front, and I'm setting up the soil temperature probe. In setup, I set up the serial port, and I'm setting up the JSON framework with a doc array for the parameters: soil temperature, soil moisture, BME temperature, BME humidity, and I've also added more recently the BME pressure, which I haven't added on this one, but we'll see it on the Microsoft Excel comma separated values. Okay, so we're just moving down to the main loop. We're just getting the data from sensors, starting off with the soil temperature probe, and we're moving down, getting the soil moisture, And depending on the command coming from the Raspberry Pi, it's turning on the relay or it's formatting it to one of the two outputs. So there's the relay command and there's the format command. And this is how we put together for JSON the parameters. Or alternatively, for Excel, we put these this format together. And my push buttons are operating on interrupts, and I haven't programmed those other than just put in stubs for future programming. So they're not doing very much at the moment. And we might actually have a look at that in operation. So we'll open up our serial port, and we're collecting data. Our Raspberry Pi is now sending the data out straight off here in the CSV format. So we might actually issue a command to turn it into JSON format. So that's one. That's still continuing. So JSON format is F1. Now we've got JSON format on the output. And if we want to turn the relay on, we just simply issue R1. And our relay goes on. We want to turn our relay off, R2. And here you can see the command has been issued and the relay is going to go off. We have to make sure that's an R2. And you can see in that JSON format, everything's quite readable. So we've gone, the last parameter is the relay status. So it's either a 1 or a 0, depending on whether I switch the relay on. And those commands, at the moment, I'm issuing them from the Windows PC using the Arduino IDE serial monitor. So what I'm going to do now is plug in the serial port to the Raspberry Pi on AM0. So we'll plug that in, see what happens. And I'm going to go across to Node Red, and we'll see what's happening. So you can see the data's coming in on Node Red just over here. And I can issue commands. So if these aren't quite working. So if I wanted CSV, but if I go back to my Arduino IDE, I can issue a format for JSON. That's what I'm doing at the moment, F1. And we might clear our serial monitor. So we're still got, go back to F2. Still coming up. We'll go back to Raspberry Pi, and that's on here. So what's happening here is that when the data comes in, it's also being collected by a data logging file on the Raspberry Pi. And we can go and have a look at that. So if we open up data logger file, which is going into, you can see our data. So this is the data that's being collected. Okay, so we'll go back to our mind map, which is just over here. That's our software. And for the Raspberry Pi, we were running Node Red, and you saw that on the program. So overall, I developed unit tests, and they all worked. I was quite happy, but I did replace the sunlight sensor with a Grove digital sensor. I was able to measure soil moisture, soil temperature, and light using, and that was in lux. And the environmental, I was able to measure air temperature, humidity, and pressure. And I was able to activate a relay and see all the data on the Arduino serial port, or alternatively, the Raspberry Pi could control everything. On the reliability of sensors, we did have a look at that. And we found the sunlight sensor was not reliable, but the replacement, the Grove sensor, was much more reliable. Okay, so some of the issues. One was the sensors, and there's plenty of opportunity for future expansion. We might have a look at that in a minute. So future versions, we will allow various configurations. So for the future ones, I'll be using units from M5 stack, and I'll be adding farm rotation with identifying what the unit ID is, the location, and the configuration. So we'll be adding that to the data stream, and I'll control light water with up to 4 different relays for either light or water. I'll be using wireless control with MQTT, and I'll also port everything across to Home Assistant. And I'll replace, for machine learning, Microsoft Loeb. I'll replace that with the Raspberry Pi AI and the C Studio AI Vision version 2. And that's the end of the upgrade for the time being. So stay tuned for a desktop demonstration. This is FarmBeats Nano, and it's sitting on top of a Raspberry Pi Model 5. So you can see the different layers. On the bottom, we've got the Raspberry Pi Model 5. We've got a M.2 with a SSD drive, and on top we've got a Grove hat. Now, this particular Grove hat uses the MM32 microcontroller. So it came out later because of a shortage of STM32 microcontrollers. So instead of actually using the Grove microcontroller for the sensors of FarmBeats, we're using a CSIRO nano computer, which is Arduino compatible, and it's hosted on a carrier which is connected to all these Grove devices. Now, originally these devices were on the Raspberry Pi Grove hat, but I've transferred it and offloaded the Raspberry Pi controller to the CSIRO Nano. So you can see the sensors. We've got push buttons. Instead of the simple DH11 temperature and humidity, I've got a BME 280, so it's a bit more accurate. We've got the original relay, and instead of using the Grove sunlight, I'm using a Grove digital sensor. And the other soil moisture sensors, these would go into the soil, and that's the soil moisture, and we've got the soil temperature sensor, and they go in and monitor our plant. And that's the Grove system on the Raspberry Pi 5 in a new FarmBeats configuration. This is my arrangement for FarmBeats on Raspberry Pi Model 5 operating under Bookworm. And what we have is a Raspberry Pi Model 5 on the bottom. The middle layer is an M.2 hat with a SSD drive. And on top we've got the only Grove hat that works under Bookworm. The previous ones were these ones. And this original Grove hat used a microcontroller with a illegal I2C addressing scheme. The FarmBeats kit came with this one, but it also used the same incorrect I2C address. So I could actually put the Grove components on these sockets on this version of the Grove hat. But what I've done is to use a CSIRO Nano, which is this computer, with a carrier for Grove components, and that's going to replace the Grove hat microcontroller. And all the components of FarmBeats, which are, you can see over here, they're all going to go onto the CSIRO Nano. Okay, so let's have a look at it in operation. And I've got the computer working with Node-RED. So we'll see that on the PC. So over here we've got data coming in from the serial port on the data logging flow, and it adds a timestamp. So if you actually see how that's been done, it's adding the time and the date. And if we go across to the debug port, you can see we've got the data from the microcontroller, and right up front we've got the date and the time added as a timestamp.